Hey, welcome back to Math with Patrick. Today's September 30th, and we're solving problem 273 from the Daily Epsilon calendar. And the answer today should be 30 because it matches today's date. So we need to find the sum of the digits plus the number of digits of this number right here. So I assume what they're saying is let's just say that number is 123. Of course it's not. It looks way bigger than 123. We would just need to sum the digits, so 1 plus 2 plus 3, and then plus the number of digits. So for this number right here, I would tack on another 3 like this. So summing the digits plus the number of digits for 123 would give us the number 9. So we just need to figure out what this number is right here, and then count the number of digits, add the value of the digits, and then hopefully we get 30. Now, as is, this problem looks kind of obnoxious because 8 to the power of 8 is 8 multiplied to itself 8 times over, and that is a lot of 8s to multiply. And then 5 to the power of 18 is even more 5s, right? We're going to have 15 of them, so nearly double the amount of 8s that we have, and somehow we're supposed to compute this product altogether. That's only 8 of them. So let me write the other 7. No, wait, 10. More than double. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay, so we have 18 5s all multiplied, 8 8s all multiplied, and then finally we multiply them together. Now, that sounds really tricky. Instead, what I would like to do is I would like to try multiplying with multiples or factors of 10 rather, instead of 5s and 8s, because when I multiply by 10s, all I do is just tack on another 0. And so fortunately, we have a whole bunch of 5s and a whole bunch of 8s at our disposal. So looking at this 1 8, this is 2 times 2 times 2. And so if I share 3 of these 5s with this 8, then I will get 2 times 2 times 2 times 5 times 5 times 5. And since we can do multiplication in any order, it's commutative, we can think of this as just 10 times 10 times 10, which is 1,000. So every time I take an 8, I should grab 3 5s with it, and that's going to tack on another 1,000. And when you multiply by 1,000, that just brings on 3 more zeros. So I'll write my number like that. Currently, we have 1 million. So another 8, another 5, we have another million. Let's put on, or another 1,000. Let's put on 3 more zeros. And I'm just going to do this just kind of the easy way and color code it and just go 3 by 3, I suppose. I know I could try to extrapolate on this pattern and really quickly go through the zeros. But see, while I was talking to you, I already almost made a mistake. I should have circled these 5s because they correspond with that 8, right? Okay, cool. And so I just want to do it a very slow, methodical way so I don't make any mistakes here. All right, seems like we have exhausted all of our 5s, which isn't that bad because we only have 2 more 8s. And so if we do 8 times all of these 8s and 5s, it's just the same thing as doing 8 times whatever this number here is. That's 1,000, so that'd be a million, billion, trillion, quadrillion. So 1 quintillion, I suppose, times 8, and that's going to give us 64 quintillion as our number today. So we need to find the sum of the digits plus the number of digits. So 6 plus 4, this gives us a 10. And then to count the number of digits, I guess we could count in groups of 3. We have 1, 2, 3, 4, 5, 6 groups of 3. And so that is going to give us 18. And then finally, we do have these 2 other digits, the 6 and the 4. And so these come from the number of digits we have. We have 20 digits in this number. And then the 10 comes from summing the digits themselves. And that is just 30, which is today's date. So that about does it. Guess we're all done. And I'm really glad I didn't have to do this multiplication in a harder way. I'm glad I was able to find this kind of multiplying by tens idea for this problem. So we're all done. Say bye-bye to Quilly. He's taking a nap right now. I'm kind of interrupting this just so you could say bye-bye. And we will see you in October. Alrighty. See ya.